Hello and welcome to the video on magnitude of a vector. So you're probably wondering, well, what is the magnitude of a vector? So if we have the vector v, and we'll represent v by the components a and b, so like that. Well, what is the magnitude of this vector? Well, it is this. So we write our vector, and we put these two vertical lines either side of the vector. That means that we're going to calculate the magnitude. And the magnitude is a squared plus b squared, and that's all square rooted. So that is the magnitude of our vector. But what does the magnitude actually mean? This is what it means mathematically, but what does it mean in words? And it's just the size of the vector. So this here, right, in a different colour, so this here is the size of our vector. Because we know that vectors should have direction and magnitude. So the direction is the angle that the vector goes through, and then the magnitude is simply just its size. So now we're going to have a look at calculating the magnitude of some vectors. Look at an example with numbers. So we've got the vector A, and that has the horizontal component 3 and the vertical component 4. So we're going to calculate the magnitude of this vector. Well, that's really easy to do. We write A, then we write these vertical lines. That means we're now calculating the magnitude, and it's 3 squared plus 4 squared, all square rooted. 3 squared is 9, 4 squared is 16, that's all square rooted. Then 9 plus 16, we know that's 25, so it's simply just the square root of 25, which is 5. So the magnitude of our vector A is 5. Vector B. And this has the horizontal component 5 and the vertical component 12. So we do the same thing as we did before. We write our vector with the horizontal lines, meaning magnitude. Then it's 5 squared plus 12 squared, all square rooted. 5 squared is 25, 12 squared is 144, and then now we have the square root of 25 plus 144. 25 plus 144 is 169, so it's the square root of 169. Well, you should know your square numbers up to 20 ideally, so we should know that the square root of 169 is of course 30. Have the vector C. So the horizontal component here is minus 4 and the vertical component is 3. So this is slightly different now because we've got a minus involved. It's no problem, we attack it in the same way. So we're calculating the magnitude. So we've got minus 4 squared. I'm just going to write that in brackets just to make it very clear what I mean. So minus 4 squared plus 3 squared, all square rooted. Minus 4 squared, well, minus 4 times minus 4, that's 16. And then 3 squared is again 9. So it's the square root of 16 plus 9. We've already looked at a sum like that, so it's the square root of 25. And that is, of course, 5. So that was slightly different because we had a minus involved. So the next example we see is going to have 2 minuses. Now we have the vector D, and both of our horizontal and vertical components of this vector are now negative. So we'll see what happens there. So we calculate the magnitude. So it's minus 6 and minus 8. So it would be minus 6 squared. Again, I'm going to write that in brackets just to make it very clear what I'm doing. Plus minus 8 squared. And that's all square rooted. So minus 6 squared is minus 6 times minus 6, which is positive 36. Then minus 8 squared, well, that's minus 8 times minus 8. Two minuses cancel out when you times to make a positive. So we have 36 plus 64. Like so. 36 plus 64. That is 100. So it's the square root of 100. The square root of 100 is just 10. So the magnitude of our vector D is 10. We now have the vector E, which is represented by the horizontal component 6 and the vertical component 9. So again, same as we've done throughout the video, working out the magnitude. So this time it will be 6 squared plus 9 squared, all square rooted. 6 squared, 36. And 9 squared is 81. So it's the square root of 36 plus 81. 36 plus 81, that's 117. So it's the square root of 117. Now, I don't know about you, but I don't know any square number that is 117 exactly. So, we're either going to have to leave our answer here as a surd, or we're going to have to leave our answer as a decimal. So we've got two choices here. If we want to do the answer as a surd, well, we need a square number that will go into this. So what are our square numbers? We've got 1, 4, 9, 16, and so on. Do any of those numbers go into 117? Well, 1 obviously will, but 1 goes into everything, so that's redundant really. 4 doesn't. Does 9? 117 divided by 9, it does 13. So we can represent this as 9 times 13. This will then become the square root of 9 times the square root of 13. The square root of 9 is of course 3, and we can't do anything more with the square root of 13 because 13 is a prime number, so it's just 3 root 13, leaving our answer in surd form. That as a decimal. To one decimal place is 10.8. So what about if we have a vector with 3 components? So in effect here we have an x component, a y component, and a z component. So 3 directions to this vector. Can we work the magnitude out of this vector? Well, we can, and this is how we do it. So we calculate our magnitude, so this will be 2 squared plus 4 squared plus 5 squared, and that will all be square rooted. So it's just interesting to see that you can use this result for a vector with 3 components. So that will be 4 plus 16 plus 25, all square rooted. So that will be 45, I make it. So it's the square root of 45. And again, if we're going to write that in surd form, 45, well, that's 9 times by 5, which is simply root 9 times root 5. Root 9 is 3, and we can't take the square root of 5, and we can't make that any simpler because 5 is obviously a prime number. So 3 root 5 is the magnitude of that vector. with this problem. So we're given the magnitude. So the magnitude of the vector A is equal to 40. So the size of the vector is equal to 40. And then we're given that A is equal to 2, which is the horizontal component, and Y, which is the vertical component. So we don't know that, so we've got to work out the value of Y. Well, how do we do that? Well, we know that the magnitude of A, so if we're going to write this, would be 2 squared plus Y squared. So we know that that would be the magnitude of A. We know what the magnitude is, which is 40. So it's 40, which is equal to the square root of 2 squared plus Y squared. Well, how do we undo this? We've got to square both sides, so 40 squared, well that is 1,600. So 1,600. That's equal to 2 squared plus Y squared. We can work 2 squared out because that's 4. So it's 4 plus Y squared. We've got 1,600, which is equal to 4 plus Y squared. Well then, to get the Y squared part on its own, we have 1,600 take away 4, which is equal to Y squared. 1,600 take away 4 is 1,596, which is equal to Y squared. So then, to get our answer, we square root both sides, so it's Y, which is the square root of 1596. I'm just going to go to the calculator here in order to work that out. So 1596, and that is, to one decimal place, 39.9. Okay, so I hope you enjoyed the video, which was the video on the magnitude of a vector. So we know that the magnitude is the size, and we can calculate that. We know what all the notation means, and then at the end of the video, we've looked at a problem where we've been given the magnitude and asked to work out the vertical component. So thank you for watching.